Hi, everyone. My name is Teng. I'm going to talk about our solution. Microsoft as the FHIR service implementer, how we enable the events of the healthcare flowing all around the world, of course, in healthcare domain. A little bit about myself. Let me navigate my slides. Yeah, a little bit about myself again. So I'm working on the Azure healthcare data service team, and we launch different product, and we create new capabilities for our product. I have roughly 4 years ish in the cloud service development, and I'm a father of 6 years old kid. Though I have slightly over more years than my experience in cloud development, but I'm more confident call myself like a developer more than a father. So still a lot of to learn. Yeah, so and a disclaimer here. So this presentation is gonna be primarily talking about software engineer discussions. I'm not a physician. I'm just a technician working in this domain to help solve the software issues. So I figure out this is like a time after lunch. So I just update my slides a little bit instead of having more like technical discussions. I want to be like a storytelling and discuss some like design thought and how customer can use our product. So this is the content outline. I'm going to talk about how event data ingested into the FHIR and why do we need events out from FHIR and how we enable it. At the end, I'm going to do a demo and of course the Q&A session. If I still got some time, I can do some bonus slide as well. So every software developer starting from like observing the problem you are having and really think about the principles and how you are going to model the world to solve the problem. We are, in my opinion, we are living in a world full of the event like the FHIR DevDays and weather, like raining, like a running session, all those stuff can change your state. Especially in the healthcare, that can be affecting your health fact. And we use the event to describe your health facts, like your blood pressure, your blood glucose, and all those stuff. And as healthcare service provider, we utilize all those data. We monitor the patient. We give them the suggestions. We give them the medications and see how they're taking them. And we generate a lot of data. So to use the data, the first step, of course, is how you're going to store the data and manage the data, right? So that will bring up the question how you are going to develop a data management system. I don't call it our relational database management system because as an implementer, you have your own choice. But at here, we are really abstracting the problem in this stack. So in the data management system, we usually start with like a minimum model to describe the interactions between different parties. We call it a transaction. So transaction has different characteristics, but the most important one is the ACID, right? You got atomic and isolated and durable solutions. Of course, it should support the concurrency as well. So usually we design the system to process all these transactions, and we call it a TPS. This is like a very typical and general architecture of a TPS. Since this is a FHIR DevDay, so we're going to talk about how FHIR as a data protocol lay in this architecture. If you already have the answer, you can see if that matches my answer here. So I think it should be seated between like front end layer and the request controller layer, because in this diagram, request controller layer will handle all the requests of the data operation for all the FHIR resources. So we really need a protocol in there. Okay, so if that's the case, how you are going to implement the FHIR? as a health provider, you already interact with a lot of problems you are having. So if you bring yourself into this position to implement the FHIR, I'm going to tell you, you are going to have to solve these problems. But we sign up for the task. We think we can develop the reusable solution for all our customers, not only one, but many, from scale like some developer only testing this in a sandbox to like recently we just got a request for millions of records per hour. So that's the scale we are supporting. Of course, we have all the legal and system team to help review all the designs and implementations at the Microsoft standard to follow all the compliances and other characteristics a cloud service should meet. So we give more than that. Okay, so as a customer, how you are going to interact with our FHIR service on the cloud? That's easy. You just have your client and do RESTful HTTP request with our service. So what the next question would be, okay, so I store the data in your service, in your solution. How I'm gonna trigger other business workflow I have in my own problem set? Before we answer that question, let's take a look at two modes of usually how the workflow get triggered. One is asynchronous, the other one is sync. So instead of throwing a lot of like technical terminologies into this meeting, I'm gonna again tell a story to help you understand the difference. So assuming we all finish all the dev days and we get into a restaurant, so you sitting here, I'm using like typical names. We described the technical problem: Alice, Bob, and Carl. Bob is a guest, and Alice is a waitress, and Carl is a chef. So Bob sit down and say, "Can I have a cheeseburger?" So in asynchronous way, Alice won't respond immediately. It will talk to Carl like cheeseburger. And Carl doesn't reply to Alice. He will just be very silently and start working on the burger for like 10 minutes. In this whole 10 minutes, Bob will be sitting there like, what am I getting into? And Alice cannot serve other guests as well. After 10 minutes, so the burger is done, Carl will say, "Hey, burger is done, Alice, go grab it." And Alice will talk to Bob like, "Here's your cheeseburger." And Bob will say, "Thanks." But it's like, you know, you have to sit there for like 10 minutes doing nothing but wait for the response. That's really painful, right? So let's talk about how does asynchronous works, which this is like a usual case in our normal life, right? So Bob sit down like, "Can I have cheeseburger?" Alice will say, "Sure, it will be coming soon." And Alice take that down and put it into the system. So put it onto a task board, like cheeseburger. And Carl will pick up the order and start working on it. And then in the meantime, Alice can go serve other guests. And Bob can maybe, you know, take the phone, do a selfie, or browse the news. And after 10 minutes, Carl gets the burger down. And then Carl may, you know, there could be a fantastic system. Carl can just say cheeseburger is down. And there will be maybe like a sound, like a beep. So Alice knows there is an order ready for pickup. So Alice will check the order and serve the order back to Bob. Bob will be happily say thanks. So this is like an asynchronous workflow. But usually we are not living in a world black and white. There is also synchronous happen in this workflow. So for example, if Bob talks to Alice and Alice don't respond, the Bob will still be sitting there like, you know, what should I do? So in this case, Alice will respond immediately like, "Oh, I already keep the order down. So you can do your own stuff." That's like a synchronous way to communicate. But the key is we have this task board as a buffer, as a transaction server to record some state, some object and its state. And in the whole workflow, the state will be changing. That can trigger other activities to start. So we bring this event-driven architecture to describe how we are going to solve the issue for triggering the other workflow. We believe this should be the best practice. So in the event-driven architecture, usually you have a bunch of event producer. You write it into a pub/sub central system, and you can have different event consumer to use the data. So you really decouple the logic of producing and consuming, right? And also you have tons of benefits for, like, it's more scalable, and in this way you don't lose the data because everything should be keeping in this pub/sub system, and it can be near real time. Okay, so after observing and bring up the solution, so we get into a new question, like how we are going to enable the event-driven architecture to our FHIR solution. So instead of start heads down and do all this fancy work and get us into more trouble, we really want to step back a little bit and step ourselves into customers' shoes, like, if we don't do anything, what customer would do? So you have literally you have two ways. One is like a puller pattern. Probably you already heard this pattern in other talks. The pattern is once you finish your data transaction, you got your data on the server, so you can have a pooling processor which keep querying the data, and also you can do export, right? And after that, you can publish to your own pub/sub system. To trigger other workflow in this event-driven architecture. There is good use and some drawback, of course, because in this way, sometimes you don't really know how much data you are getting into the FHIR server, and you don't know how to scale the processor. So you need some mechanism to help you scale, horizontally scale the processor to do the better job. And also, when you put a lot of query on your FHIR service, it actually adds more load to your FHIR service, which should be serving the transaction options as a primary job. The other one is post-read. Why I didn't mention pre-read, because you don't want to emit any event that doesn't happen yet. So we are going to do like post-read. But the problem is, if you are going to do post-read, step one, you're going to complete your data transaction with FHIR, and step two, you're going to push an item into your message broker or pub/sub system. What if between these two steps, the system crashed? You cannot assume your system is robust and never get down in a distributed system, because sometimes it's just like infrastructure issues or runtime issues. So you really cannot assume anything. So how to solve that? You may have to add another transaction layer to guarantee step one and step two should be completed as a unbreakable unit. That's a lot of work and pain, right? So we sign up for the task. We want to bring this capability as a PaaS offering. What we will be doing is we are the FHIR implementer, so we know how to interact internally with our solution rather than just a customer and working around with our black box FHIR server. So step one, when we finish the transaction, actually we are going to capture this change data. So if it failed, the data change will never get captured, but it failed. Customer know it's failed, so they will do something again. And step two, we are going to have a long-running agent keep scanning the data changes and convert them into the data, the event format, and emit the event. We call it the event sourcing pattern. And the next question is, we already captured all the change. What should we do next? We need a pub/sub system. And to do a pub/sub system, again, you are going to do all this. That really scared us at the beginning. Like, are we sure we only have this many people but do this works? So we explore other options within Azure. gladly, we are one Azure, one Microsoft. We have another service serving tons of traffic within the Azure to facilitate other workflows, which is called Eventdriven. So Eventdriven also gave you a lot of integration solutions on the shelf. You can do a bunch of click and trigger Azure function, Event Hub, blob storage, service bus, and logic app, which is my favorite. I'm going to talk about that logic app later, a little bit more later, and the webhooks. So you don't have to have your event consumer living on the Azure. You can have it on premise, maybe with other cloud providers. But as long as there is a webhook, you can interact with your event. That will be great. So this is like a quick example about how we're consuming the FHIR event within the logic app. As you can see here, we have a trigger. So that means whenever there's something happen, so we are going to trigger something. Oh, sorry, because I want to point to you. Sorry. Yeah. Maybe I can use this one. No. Okay, I'll use my mouse. So you have a trigger here. You can configure the trigger like, oh, there is if there is an event emit from my FHIR, so please trigger other actions. The first action I'm doing here is another HTTP action. The reason for adding this layer is at this moment in our event, which is still a MVP but GA version, we don't give you the real content of the FHIR because of we don't want to expose the PHI and PII at this moment. So we only give you some system metadata, but with good enough for you to make a query to our server and pull the FHIR resource based off those system metadata, then you know the current version of your resource. And after that, I added another layer called condition. So with the condition, you can look at your current version of your resource and parse some of the content from there. So this is really like a filter, right? So you can say, if this happened, do something, do these things. And if that doesn't happen, do something else. In my workflow, I just choose, okay, so if I got more time, I can do a real-time demo with you guys. So in my workflow, I'm going to say, if there is an observation generated for blood pressure, please notify me with an email. So you can see that really integrates not only with Azure, but your Office suite. Of course, we are pretty inclusive. You can interact with other action like PDF, like Adobe. I didn't list them out like Twilio. So we have a list of offerings you can explore. That's pretty cool, huh? So we are going to take a step back and look at new opportunities. If we are going to have the event grid serving the pops up functionality for our FHIR service, what other opportunities we have? We open the door to two new whole worlds. Okay, so let's examine our solution at this moment. We have our FHIR of the Azure Health Data Service. We have the healthcare events flowing, like your heartbeat, your oxygen saturation rate, whatever healthcare events getting into the FHIR service. And we are going to trigger workflows on the Azure. If you have on-premise, that's fine. We can trigger that workflow too, as long as you have a webhook that can interact with us. Oh, by the way, we do very strict authentication with your webhook. And if you are using other cloud providers you don't want to move at this moment, that's fine. We can also do that. So we think this is a pretty event-driven architecture we are bringing up to here. We call it enable the event-driven in whole healthcare world. And next one, I think you guys may think like, oh, these guys talk about a lot of fancy stuff. What's the real example in the real world? I'm gonna do a quick demo of what we can build with all this solution, not only with the FHIR, but with whole other services of the health data service, Azure Health Data Service. If you joined the session by our general manager, Doug, yesterday, you may know that we not only offering the FHIR, but also something called a MedTech, which give you the IoT connector that help you massage the data from all the devices and ingest into our HDS. Oh, by the way, I have whole colleagues sitting in the front row. So yeah, we are all working on the MedTech team. If you got a question, please ping them. Okay, so for this demo, I'm gonna tell you how we can monitor the running stats with the Apple Watch. Of course, we're inclusive, so we're gonna test with Google Fit application and platform. So, not lying to you guys, but this morning I take a dev day run this morning. Yay! And I was wearing my Apple Watch. So I got all the heart rate. I already set up the link between my Apple Watch and my phone. So I got a Google Fit application on my phone. It can help you get the data into the cloud. And once it gets into the cloud, we have a solution to talk to the Google Fitness API and get the data into our IoT connector, because I'm going to tell you the other problem that our IoT connector can solve. But yeah, think about how many devices you can wear on yourself and your customers. There are a bunch of data, right? And they are coming in real time, large volume. We have IoT connector help you solve that problem. And after that, since this is a FHIR DevDays, so I'm going to emphasize on the FHIR a little bit. So we are going to get in the data into the FHIR. And after that, if I detect, oh, there is like a spike, in my heart rate, that means I'm doing something crazy, maybe like exercise, right? So I'm going to examine the data and send me like an email, trigger an email. Oh, you did a great job for your exercise. I did this morning, so you see a lot of duplicated emails. So I will say something, developer usually say buggy, but I will fix it by today, hopefully. Okay, so here's the FHIR resource, actually the observation resource. And if you cannot see it clearly, I prepare something for you. You can take your phone and scan the QR code. It's just a file on the OneDrive. So don't worry about the security too much. In the meantime, I'm going to explain what does it mean in our data payload. So the first one is subject. We take a reference to the patient, and also we take a reference to the device resource. We have those unique ID that pointing to unique person and unique device on our FHIR service. And you can set up the correlation between all these subjects. So when you, for example, you're a developer or you're a doctor, when you see this, oh, this happened, this person with this device did something for this observation. And effective period, that was this morning. And for this value sample data, so here, I'm going to talk a little bit about IoT connector. So Google Fit, when you do some exercise, it will pull the data of your heart rate like maybe 5 seconds. That's tons of data. So that if you are going to talk to your FHIR service directly, that will make your FHIR service pretty chatty, like tons of data. So you're going to handle all this data operations. So we have a IoT connector help you to group the data. So we hold the data in a certain period before we send it to the FHIR. So we help you to reduce the load of your FHIR service. This is like the format that I believe we invented. So when you see E, that means empty. There is no heart rate monitor or metrics at that moment. And all the other numbers are real-time numbers. So, and with our solution, you can configure the period of each like a data metrics or data point in this whole array. And also you can configure how long you wish to group the data. So then we batch the data, we send them in a whole batch to reduce the load on the FHIR. And of course, we help the customer to transform the data. So they don't have to, oh, if I want to get the data into FHIR, I have to maybe do a lot of massage on my own device data, which already have some shape. And that's, a lot of pain and bring a lot of like ramp up requirement for our customer. So we set up the task and we'll help you do that. This is the architecture for the demo. So when I was running this morning, I wear my Apple Watch, which actually writes the data into the health kit on my phone. It synced with my phone, so it will write into the health kit. The Google Fit, which I already give the permission to pull the data from the health kit, and it will sync all the data into the GCP, which there is an API called Fitness API. So we have a GitHub open source solution called a Google Feed on FHIR, which is also developed by one of our colleague, Nate, on our team. Probably you heard it if you joined the sessions before. He did some demos in the past session or past DevDays as well. So we use that solution to keep pulling the data from the Fitness API and ingest them to the IoT connector, which we call the MedTech, because we want to expand the spectrum of the MedTech. We will probably do more things. But in this case, it's IoT connector. So we connect the IoT data with the FHIR. And step 6, we group the data and we get into the FHIR. And like I mentioned before, we use the event grid to help fan out the data. And in my demo, I was still using the Logic app, which is my favorite, to kick off the email when there is a spike happen. So I can use condition like, oh, in this period, if the average heart rate go beyond maybe like 150, so there might be some exercise this customer or this user is doing. So other integration ideas. As you can see, with the Logic app, we can do a lot of things. We can trigger all the other PaaS offerings on the Azure. We can work with other, Microsoft or other like business tool suite. And if you have on-premise, we can, by the way, the way I think it can connect is use the Logic app to trigger some function. And with the function, you can set up a private network, use the VPN with your on-premise network, and all the data can securely get into your local network and enable other workflows on your local data storage. So at this moment, you may wondering what about the FHIR subscription? If you joined the session by Gino, like days before, so you might have heard about the standard. It's not a normative at this moment, but we work as a same team. We work with same, Microsoft. So when the time is ready, we will help integrate our solution with the FHIR subscription as well. And this is, but in the meantime, if you want to explore, okay, so I like your solution, I like your Azure FHIR service, but I really want to test FHIR subscription. We have a GitHub open source for you. All right, I think I'm running right on my expectations, so I can start the QA session. And in the meantime, if you want to learn more about how to do this, here are the links. Sure. Is there any question from remote and local?
So I'll hand out the microphone.
Okay.
Brian had his hand up first.
Thanks for the talk. At one point you talked about transforming the data, which I see as like kind of hard. Do you use the, I think Microsoft, you have the kind of FHIR converter library that uses liquid templates or something. How do you help your customers convert data from the Apple Watch format to FHIR?
Okay, that's a really good question. So we have a service called a FHIR converter. That converter is primarily solving the problem of converting the documents from old HL7 or other healthcare standard. But for like Apple Watch, maybe like other monitor like Fitbit, so they don't really follow all those kind of historical data protocol. So they have their own like runtime logic or their own business logic to shape the data. So we give this opportunity, like we give this like a template mapping file. So customer can use those template mapping file to map the data shape of their self and to the data shape we expect to see. We examine the liquid, but the performance doesn't meet our real-time processing. We have our own like templating language, but primarily we are using JSON. So yeah, we have Rob and Mackenzie sitting in the front. They are helping the customer to do a lot of mapping work. So if you got any question about the mapping, you can reach out to them. Yeah, next.
One more question. Did you have?
For the events that you are sourcing into Eventgrid, is it like, what is it? It's actually a FHIR resource that you're sending?
No. As I said, we only keep the metadata. We only keep like a version ID and the resource type. So we only keep. So let me take it back. We only keep the system metadata for customer to query the FHIR service to get the original resource content. The reason is we don't want to handle the security and privacy concerns at this moment.
So how do you know what changed? I mean, you basically said it's
There's a
changed
version.
Okay.
Yeah.
Anyway, like, so how do you write the rule then? Like to route it, you have to first get the actual resource. You said if it goes beyond a certain threshold in your example, right?
Mm-hmm.
So if you're just getting metadata, how do I write the rule then?
That's a good question. Let me step back to here. Actually, let me do this. Here. Okay, so yeah, when we get the event triggered, we know the event content within this step. And the next one is we're going to get the system metadata and then make a query with HTTP action at this moment. We make a query to our FHIR service with those system metadata, like for this ID, for this version, give me the current content. So at this step, we know the content. By the way, we use the managed identity to interact with our system. So we use trusted Microsoft trusted solution to handle the data with all the privacy and compliance concerns. Does it answer your question?
Even if there is not if the event has not changed the threshold, would you still make a call, or would it only come to you?
That's a very good question. At this moment, we will still make the call. But in the future, we may do some pre-compute, so we don't have to query the server again. The FHIR service doesn't charge extra for using the event, but all the other, as you can see, this is a logic app. This is another like Azure offering, but they charge. Any question? Okay, yeah, so I just want to show the bonus. So if you have time, you can take a look. So yeah, there is a store called Home Depot in United States which sell tools. You can use those tools to help your home improvement. And for us, we are here to provide the tools to help our customer. You can use our solution to improve the healthcare without rebuilding them again. Okay, thank you, everyone.